Hi everyone, thank you for joining me in this video where I'm going to try to explain what relative masses is all about. So to begin, let's look at the word relative. Well, when we look at the word relative, usually what we are referring to is that we are comparing two things, right? For example, if I were to say, what is your height relative to another person's height? We are making a comparison. So when we look at the word relative, another way to look at it is that we are looking at ratios, right? Because when we look at ratios, what we're doing is we are comparing two things, or maybe three or four, right? The idea of ratios is that we're just making a comparison. So for example, let's look at these two ducks over here. The duck on the left has a mass of 1.2 kg, while the duck on the right has a mass of 3.6 kg. If I were to ask you what is the ratio of their two masses, you would tell me that the ratio goes something like 1:3. Notice I have got rid of all the masses. No more kg involved, it's just purely a ratio 1:3. And that's really what relative means. If I were to ask what is the relative mass of this big duck to the small duck, another way to say it is that, well, it is 3 times more. It weighs 3 times more than the small duck. Notice that no mass, no unit is involved over here. So that's what relative is all about, is dealing with ratios. And in ratios, we no longer make use of units. So then the question comes, can I do the same with atoms? Right? Can I compare the masses of atoms? Don't really care about the units anymore, just compare the masses of atoms. Well, we can. More specifically, when we talk about the masses of atoms, we don't really bother about the electrons. The mass of electrons are quite negligible. Instead, we are dealing with the masses of the protons and neutrons. For example, let's look just at this hydrogen atom over here. In this hydrogen atom, it has one proton. The mass of one proton is around 1.66 times 10 to the power negative 27 kg. That's extremely small mass. Or in grams, it's around 1.66 times 10 to the power negative 24. Now that's quite a mouthful, right? To say that hydrogen has a mass of 1.66 times 10 to the power negative 24 grams because it has one proton. Quite painful to say that. So we have a easier way to represent this. Sometimes you may see the word AMU. AMU represents this amount of mass, 1.66 times 10 to the power negative 24 grams. So what is the mass of this hydrogen 1? The mass is simply 1 AMU. That's because one proton weighs around this much mass. What about carbon? Right? What about carbon 12? We see that carbon 12 has 6 protons, 6 neutrons. That also means to say that it has around 12 times 1.66 times 10 to the power negative 24 grams. Or another way to put it, more simply, is just 12 AMU. Right? So now we know the actual mass of one hydrogen and one carbon 12. But if I were to ask you, what is the ratio of these two masses? Well, it would just be 1:12. Notice no more units involved. That's because we are just comparing relative to each other. What are the masses? Relative to each other, hydrogen is just 1/12. Hydrogen is just 1/12 of this 12 carbon atom. So that's what relative masses are. We're dealing with relative masses. We are no longer dealing with the units. We are just comparing between the masses and just finding a ratio. Now, next video, we're going to go into a little bit more on the definition of what relative masses are. And then we're going to look at the various types of relative masses. Okay, so stay tuned and see you in the next video.